Today we'll be looking at quadratics. Our objectives will be to introduce quadratics, to calculate the axis of symmetry and vertex, to graph a quadratic by hand, and to graph a quadratic using the calculator. So let's begin by just discussing quadratic functions. First of all, we can recognize a quadratic function because it can be written in the form f of x is equal to ax squared plus bx plus c, where a is the number in front of the x squared, b is the number in front of the x, and c is the constant that does not have a number with it. Let me give you an example of a quadratic function. Y is equal to 2x squared minus 4x minus 1. Now, notice that it is written in the correct form, so it is a quadratic. And let me show you what the graph of a quadratic will always look like. This shape is called a parabola, and this is what quadratic functions will always look like. I do want to point out, however, that sometimes the parabola can open this way as well as the way you see in the blue line on your screen. As a matter of fact, let's talk about how you know which way the parabola will open. If the leading coefficient is positive, the parabola will open up. If the leading coefficient is negative, the parabola opens down. Well, maybe we need to talk about the fact that this is the leading coefficient. It's the number in front of the x squared. So if that number is positive, the parabola opens up. If that number is negative, the parabola opens down. So in this case right here, this parabola opens up like a cup, and so this one has a positive coefficient, and that's exactly what you see right here. I don't know what the equation for this parabola would be, but I do know that it would be a negative something x squared because this parabola opens down. Now, let's talk a little bit more about the parabola. There's another thing I need you to understand about it, and it's what we call the axis of symmetry. Before we talk about it in terms of the parabola, however, I want to take you on a trip down memory lane. I want you to go back to when you were a small child and somebody might have handed you a piece of pink or red construction paper and asked you to cut a heart out of it. They gave you those little blunt scissors that you didn't think you could cut anything with, and you tried to cut a heart. If you were a person who wanted your heart to match on both sides and look very even, you may have folded your piece of paper and cut around the outside edge. If you did that, what you got was a heart that was symmetrical. Both sides were the same. And that crease where you folded it is what we call the axis of symmetry. Well, it turns out that a parabola has an axis of symmetry as well. It's the line that runs right down the center of the parabola, and it turns out that if you folded the parabola on the red line, the right-hand side of the parabola would line up exactly on top of the left-hand side of the parabola. This is called an axis of symmetry. And an axis of symmetry is always a line. As a matter of fact, it's going to be a vertical line. Can you tell me what the equation of this red line is by looking at it? We've done that before, so I hope you can. Equations of vertical lines are always x is equal to something, so in this case, it's x is equal to 1. So the axis of symmetry for the parabola you see on the screen right now is x is equal to 1. I want to talk to you now about another important aspect of this parabola. It also has, right here, what we call a vertex. And the vertex is, in this case, the lowest part of the parabola. By the way, if the parabola had been shaped like this, it still has a vertex. It's just that it's the top of the peak in that one. So what is the location of this vertex right here? Well, it's a point, and it's 1, -3. Now, it is no coincidence that this number right here is the same as this. As a matter of fact, I need you to remember that when you're calculating a vertex, the first thing you need to do is calculate the axis of symmetry, and you'll have the first half of your vertex. We'll talk about doing that a little bit more in a minute. But right now I want to talk to you about another concept dealing with the parabola you see on the screen. Because this parabola opens up, there's another way we can identify this point. We can call it the minimum. It's the bottom or the lowest part of the parabola. So you will hear the word vertex used, and that's a generic word for a parabola that opens up or down, either one. But the term minimum can be used to describe the vertex of a parabola that opens up. Got any guesses for what this one might be called over here? Well, hopefully you're thinking maybe a maximum, and you would be right. So if your parabola opens down, it still has a vertex, but this time it turns out to be a maximum. And that's going to be important to us in a little while. Let's look now at another quadratic function. Still of the same form, and this time it is y is equal to a negative 4x squared minus 8x plus 2. Without doing any calculations, I hope you can tell me which way does this parabola open? Because this is negative, I know that the parabola should open down. And so here's what it looks like. The next thing I want to know is, what is the axis of symmetry? Well, it's that fold line. Can you tell me what it is in this case? That's what it looks like. And the equation for it is x is equal to negative 1. The other piece of information I need is, what is the vertex? Well, it's located right there. Can you tell me what that point is? It's the point negative 1 comma 6. Once again, remember, this number and this number are the same and will be every time. So at this point you could identify for me that the parabola opens down, you can tell me its axis of symmetry, and you could tell me its vertex. But what if I didn't give you a picture? What if instead I gave you the equation and I asked you to calculate for me the axis of symmetry and the vertex? Is that possible? Well, you know it is, so let's go on and see if we can do it. This time I'll give you this function. Once again, notice that it is quadratic. And the first thing I'm going to ask you to do is calculate an axis of symmetry for me. Now we're going to do this without drawing a picture of this. Mathematically, we're going to calculate that axis of symmetry. So we need a formula for that. And it turns out that the axis of symmetry can be calculated with x is equal to negative b over 2a. Now let me remind you what those a's and b's are. The a is the number in front of the x squared, the b is the number in front of the x, and the c is right here. So if I want a negative b over 2a, then I need to plug in a negative 12 divided by 2 times 3. That would give me negative 12 divided by 6, or a negative 2. Now let's go one step further with this, and let's calculate the vertex for this same parabola. Well, its formula looks a little bit scarier, doesn't it? But not if you really look at it carefully. Notice that this part right here is what you've already done right here. So what that's telling you is that this number right here is what goes at the beginning of your vertex. And then if you look at this, what this says is you calculate f of that number. Let me put this into English for you a little bit better. What it says is, once you have the axis of symmetry, you know the x value of the vertex. To find the y value, you take this number and plug it into the function. You evaluate f of negative 2. Let me remind you, we haven't done that in a while, but it would be finding f of negative 2. Well, you know how to do that. Why don't you pause the video, calculate f of negative 2, and come back to check. F of negative 2 is equal to 3 times negative 2 squared plus 12 times negative 2 plus 7. That gives me 3 times 4 minus 24 plus 7 for a negative 12 plus 7, or a final answer there of negative 5. Now, what that means is this. Your vertex is an ordered pair of numbers. The x number came from right here, whatever the axis of symmetry is. The y number comes from plugging that axis of symmetry in to right here and calculating this number. So that's where the y value comes from. Without graphing this, then, I want you to notice that what we've done is we've taken this quadratic equation and we have calculated its axis of symmetry, which is x is equal to negative 2, and its vertex, which is negative 2, negative 5. Now, one of the reasons we would want to do this would be if we were going to graph a quadratic equation manually. And guess what? Life is so good that that's exactly what we're going to do. Instead of starting from scratch, though, I'm going to use the information you've just calculated. We're going to use the same quadratic function. And I want to remind you, our steps would be to calculate the axis of symmetry, which we've already done, and in this case was a negative 2. Once you have that, if your task is to graph a quadratic equation, I think your easiest thing to do is to go on and draw that line so that you can see that your quadratic equation has that for a fold line. Next, we want to calculate the vertex. Remember, we're going to plug that negative 2 in, and we've already done that, so we know that it's negative 2, negative 5. Now remember, this number came from the previous example. At this point, you would want to go on and plot your vertex. So there it is, -2, -5. Now there's really not a nice way of graphing quadratics like there are linear equations. With linear equations, we might talk about graphing by using the slope-intercept method. But when we go to quadratics, our method is going to be plotting points. It's been a while since we've done that, so let me remind you. We would start by building a chart. Let me tell you what you need to put in always as your first items in the chart. It's your vertex. The reason you want to go on and put this in your chart is it will help you in making these choices. Let me show you what I mean by that. We know that the axis of symmetry is at -2 right here. Well, our next pick numbers for x's are going to be these. We're going to move one position to the left and one position to the right. That gives me a -3 and a -1. For our next picks, we're going to move one more position and one more position. That'll give us a -4 and 0. And the reason we do that is because we know that the parabola is centered on this line. So these 2 points ought to be symmetrical, and these 2 points ought to be symmetrical. So that's how we pick those points. Now hopefully you remember how to plug these in. You're just going to do f of -3. Why don't you pause the video, do f of -3, -1, -4, and 0, and then come back and let's check. When I plugged in a -3, I got a -2. For the -1, I also got a -2, and that's no accident because remember these points are supposed to be symmetrical. Let's plot them and see what that looks like. Hopefully when you see this you can see that symmetry happening. The next x values I need to plug in are -4 and 0, and once again you should see that symmetry happen. This one's a little bit high up on my graph here, so let me just go on and put it in. And then once you have that done, you're able to draw your graph. So that's what your parabola would look like if you drew it by hand. Let me remind you of your steps. You would calculate the axis of symmetry, you would calculate your vertex, and then you would choose these points so that you would see the symmetry, and then plot them once you've calculated their y values. Now what we want to do is see if we can graph a quadratic using our calculators instead. Let's take this same quadratic equation and see if we can do this one on our calculator. Well, first of all, I know that you can go to y equal and you can enter this, and this is what you see. I understand you can probably already do that, but there's much more to using the calculator for doing quadratics than just drawing that picture. What if I now ask you to find me the axis of symmetry and the vertex? Can your calculator help do that as well? And the answer is absolutely. So let's look at what it can do. If we want to find the vertex, the steps for doing this using your calculator would be second, and then trace or calc. You'll look down that list of choices and you're going to be amazed that you don't see the word vertex. But what you do see are the words maximum and minimum. And I want to remind you that in a parabola like this one, is that point a maximum or a minimum? It's the bottom of the parabola, so it's the minimum. So because it's a minimum, we want to choose option 3. Your calculator should then come up and say left bound. And so here's what you should do. When it says left bound, you move the blinking cursor to the left side of the minimum and then enter. Now let me make sure you understand what I mean by that. You have this little blinking cursor here and you can move it all around this curve. It's asking you to set for it a left bound. It is saying give me a position on the left hand side of that minimum. It's then going to ask you for the same thing on the right hand side. And what it's going to do now is find the minimum in between the bounds that you have set. And by the way, that'll be the one we're looking for. So once you have your blinking cursor over on this side, you hit enter. The calculator will then say right bound. When it does, you need to move the blinking cursor to the right side of the minimum and then hit enter again. Once you've done that, the calculator will say guess, and by now you should realize we are never going to argue with what it guesses. So you hit enter again, and it will come back and say the word minimum. Notice it will not say vertex, it will say minimum. But what it has found is the minimum value right here on your parabola. Now, I want you to notice here, it has negative 2.000001. It's safe for you to round that to a negative 2. Now let me be very careful here with how I say this. Some of you will tell me I have a negative 2.375. I'm going to round that to 2. Let's don't go there. But when you have 0.000001, it's safe for you to tell me that that's a negative 2. Some of you may see on your calculator something that looks like this, negative 1.999998. That's also safe to round to a negative 2. When you're only off by this little bit way out here, whether it be over the 2 or under the 2, it's safe for you to round that. So what we now know is this. Our vertex is negative 2, negative 5. Now please remember, you never saw the word vertex anywhere on your calculator, but your calculator found it for you. It is negative 2, negative 5. What if I now ask you for the axis of symmetry? Can you tell me what it is? You should recognize that the axis of symmetry is always the x value of the vertex. So the axis of symmetry in this case is x is equal to a negative 2. There's one more piece of information that your calculator can do for you, but I don't have room to do it here, so let's look at one more piece. We'll use the same function, but this time we're going to create a table using the calculator. Our steps for that will be second, graph, or you'll notice it's table, and when you enter that, this is what should come up on your screen. What I have here is the table that we created manually a minute ago. Now, the nice thing about it is your calculator has created that for you. Remember, we said that the vertex is negative 2, negative 5. A minute ago, you plugged in a negative 1 and you got a negative 2. You plugged in a negative 3 and you got a negative 2. You plugged in negative 4 and you got 7. And you plugged in 0 and you got 7. Your calculator has just done this for you. Now, if yours is not looking like mine looks right here, and you don't have these values centered right here like I do, where your vertex is right here in the middle, use your blue arrows to scroll up and down until you see this part of the table. So it turns out that your calculator can do everything that we did by hand a minute ago, and by the way, quite a bit faster. I would suggest that you practice doing several of these because it's important that you remember the calculator steps for doing this. Let me leave you with my thought for the day. It's from Sir Winston Churchill this time, and it's the price of greatness is responsibility. I'll see you again soon. Bye-bye.